So great, we can get the median of any number of integers. But what about reals? Another SCADE feature to support genericity is the ability to talk about generic types. A generic type is characterized by the fact that its name starts by a quote. You can use a generic type in any operator, both for its inputs and outputs, and also for its internal variables. A generic type means that you don't know at design time what this type will be. So let's replace in our design here every reference to int to a generic code T. So here in my array V, I do have an array of n code T's, and my output is also going to be a code T. By using the same code T for the V type and the M type, I am actually saying that M has the same type than the elements of the V array. Now let's see what it changed. Let's check our root test operator. No errors. Let's generate the code. Okay, if we look at the generated code, we see roughly the same files. Okay, no significant change. We can open them and see that we have still an array of 5 integers for this one, an array of 12 for that one, an array of 10 integers for that one. Okay, good. Now let's change a little bit our test root operator and say its first input is going to be an array of 10 reals instead of integers. And let's take the third input and say it's an array of 5 booleans. Okay. Does it still work? I can check. Of course, I forgot to change my outputs. So this one needs to be a real, and this one needs to be a bool. And you see here that the type checker of SCADE still verify that the types are correctly matching. So if I check it, yep, good, it still works. Let's have a look at the code. And you will see here that the files are slightly different. You see that the code has been generated for the median of 5 booleans, for the median of 12 integers, and for the median of 10 reals. We can do a quick simulation to check that the behavior still works. If you have had a look at the code, you know that it will work. Let's verify it anyway. Okay, so for our first input, let's say this is a real point value, so I can use that. This remains an integer, so let's say 456, and let's put the last value to true. If I do one cycle, we see that the behavior is the one expected. Okay. So it works, and it will work with any type. I could use much more complex type like structures. I could have an array of structures. I could get an array of arrays, or whatever combination I want. But do we really want the median to work with any type? Actually, not really, as we need to be able to define an order between values in order to be able to compute the median. So what we will do is we will restrict code T to be able to represent only numeric types. So I go here and I say that code T is going to be declared as numeric. That means that code T can only be an integer or a real, and any other type will be rejected. So let's check the model again, and now I do have an error. It basically says that bool is not a numeric type. Okay. So I will have to change this for an integer or for a real to have it working again. Okay, let's make that a real, and if I check it again, of course I need to change accordingly my output again. Check. Good, it works.